Hello guys, today we are going to discuss transformer and mutual inductance. So here this is a problem related to transformer. Here we are going to find the mutual inductance, the induced voltage in a primary coil and induced voltage in a secondary coil. So let's start from uh, uh, from uh, from case 1. So to find the mutual inductance, we have several formulas to find the mutual inductance. In the first case, if we are going to find the mutual inductance, we got a formula. Now this formula can be used to find the mutual inductance, but here for our simplicity and for data given in this problem, we can easily use this formula: coupling coefficient and a product of inductance of a primary coil and secondary coil. We can easily use these formulas. Now start with the formula number 2. Mutual inductance can be easily find. So so here the value of mutual coupling coefficient is 0.6 and millihenry and 800 millihenry. So let's solve this. Now if we solve this, our equation will look like now so our final answer will 240 millihenry. Now we found the value of mutual inductance, which is 240 millihenries. Now in part B, what we are going to find, we are going to find the induced voltage in the primary coil. The condition here is the flux at the primary coil changes at the rate of 450 milliweber per second. So according to parallel, the induced voltage in the primary coil now so according to parallel, the induced voltage inside the induced voltage in a primary coil is equal to the number of turns in a primary coil and the rate of change of flux linked to the primary coil. Now if we put all the value in this equation, what happened? So here turn is 50, 450 milliweber per second. Now if we solve this, it gives us 22.5 volt, 22.5 volt. So the induced voltage according to this specific condition is in the primary coil is 2.5 volt. Now in C case, what we are going to find, we are going to find induced voltage in the secondary coil for that same rate of change. So so according to Faraday law, that same rate of change. So what happened when we put all these value, turn here is 100, so that rate change is 450 milliweber per second. So if we solve this, it's equal to 27 volt. Now we found the induced voltage which is equal to 27 volt in the secondary coil. Now in the D case, what we are going to find, we are going to find the induced voltage in a primary and secondary coil if the current IP changes at the rate of 0.2 ampere per millisecond. So here for the primary coil we got a formula, a rate of change of current. Now so if we put all these value, so 0.2 ampere per millisecond can be right like 200 ampere per second. If we solve this according to their specific condition, which is equal to 40 volt. Now so according to this one, which is equal to 40 volt. Now induced voltage inside this secondary coil, so we got a formula, now we can say that from where we got this formula. So induced voltage inside secondary coil is equal to number of turns of secondary coil and the rate of change of flux. Now if we multiply numerator and denominator with this term, Now what happened? So this term is actually equal to what? This is actually equal to mutual inductance. And now let's put all the value in this equation. If we put all the value here in this equation, so mutual inductance is 240 millihenry, and this rate change is 200 ampere per second. Now if we solve this, this is equal to 48 volt. Now we solve all the condition here. So this is actually a transformer which we use mutual inductance formula.